Yeah, so I'm Michael Droettboom, the other co-lead author of Matplotlib. Thomas Caswell is also here today. Everything I'm going to show today works in version 1.5, which came out 2 weeks ago. So you can use all this stuff today. So here I just have some imports. Matplotlib is alive and well. We're officially a NUM-focused project now. Thank you very much. So they're managing all of our sort of nonprofit financial management stuff. We're able to accept money, spend money. This is really awesome. We have a lot more developer resources available than we have had lately. So I'm very excited about that. This is our release schedule on October 29th. As I said, we had a version 1.5 come out. At the end of this year, we're going to put out our version 2.0, where we're changing all the styles. Everything's going to look a lot more modern. But anybody who's currently tweaking their styles and being very careful with it, things may break. That's why we're calling it 2.0. But we're only going to change styles. We're not going to add a ton of other features. So you can kind of continue to live on 1.5 for a little while, but we're not going to support that forever. We're not going to repeat a Python 2 to 3 year, decade-long transition. And then around the second quarter of next year, we're going to have 2.1, which would, again, be sort of a regular feature release. I'm not going to talk about the features that are in there yet. We're still trying to milestone what that'll include. So here's some demos, all of this working with 1.5. This is not a new feature, but it's a feature that I think is finally totally ready for prime time. Is the notebook ag backend, which is, or the web ag backend. It's a fully interactive way to use Matplotlib in an IPython notebook. And it works really fast, and it works great. And importantly, you have the same programming model you've always had in Matplotlib. So if you've written GUI applications that use Matplotlib events in order to fire things and make things go off, all of it works without any code changes at all in an IPython notebook. So to demo that, I can't see the trace back here. Let me back out to this. OK, I think it didn't register this. All right, try this again. OK, so this is that interactive notebook thing. It's taking mouse events. If I type keyboard events, you see it's typing out what I'm typing. Those are going to the Python kernel and coming back as new images. Even really cool things like Matplotlib animation works just fine in the notebooks. So that's all rendering the animation in the Python kernel on the Python side, sending images to the browser and at a pretty high frame rate. I'm going to close this one because it eats up a little CPU. We have styles. Again, this isn't new to 1.5, but in 1.5, we've really kind of ramped it up. We have a ton of styles available now. So if you don't like the default Matplotlib style, you may not like the one we have now, you may not like the one we choose as the defaults for 2.0. It's very easy. It's one line of code to change the style of your plots. So to demo some of that, we'll take this plot, and we're using the 538 style here. So that makes your plots sort of look like the 538 website. Sorry, they're all cropped on the bottom a little bit there on what you're seeing. It's also very easy. You can fetch styles over the internet from an HTTP request. So you might discover a style online that you want to start using. It's one line to just use an HTTP request. It looks like that's failing. I'm having trouble getting on the network here. But if I were on the network, it would go out and fetch a style and cache it locally and use it. We now have the automatic updating is a lot better. It used to be in Matplotlib, you plotted something and then you changed a few properties. Sometimes that would update the plot, sometimes it wouldn't. We've really kind of cleaned all that up. Thomas did a lot of that work. So if I plot something here and say, I don't like that line style, I want it to be green, you really just, with one line, everything, you just change it and automatically it updates. Oh, sorry, I realize you're not seeing the code I just ran. The code I just ran basically says line set color green, okay? And it makes that change. String labels to bar plots. It's sort of embarrassing. This never worked till now. But now, if you can very easily just put string labels. Here, we're using fun Unicode symbols, but they can be any string. We have this new thing called a property cycler. So we've always had a color cycle. When you plot a line, it starts as blue, then green, then red, or whatever the order is. Now you can do that with any property. So it can be colors, it can be the dash style, it can be the width. Anything you can create different cycles of, and it'll generate the cross product of all the different styles. So here, with sort of one line, I've made a very simple. I don't know why it's doing that. It made a very simple style that might be suitable for print, right? So rather than using colors, I'm using dash styles, and it'll automatically choose from the dash styles each time I plot a new line. You can do fancier things. This example, again, I'm sorry it's cropped, but I'm putting, as the cycler, I'm cycling through 4 different color maps. And then each time I plot, it will choose a different color map. Of note here, this right here is our new color map by Nathaniel called Viridis, which is very uniform and very translates to black and white very well. There's a lot of research that have gone into this new color map, and in 2.0 it'll be the default color map. So no more jet as the default, which is really probably the worst default you could imagine. We have labeled data support. So here I'm loading a CSV data set of cars, and it has their weight and miles per gallon and various things in the columns. And now with really just this one line of code, we can pass in a data frame to plot and say we want to plot miles per gallon versus weight, and use horsepower for the color and the number of cylinders for the size. And sorry, it keeps going off the bottom of the screen. But with basically that one line of code, you can plot a data frame in Matplotlib really, really conveniently. So that's a really kind of powerful new feature. This one's really brand new in 1.5. I think there's a lot of places we want to take this that we will down the road, but the basics are all there. It's easy when you combine these sort of cycling and labeling and all these things. Suddenly you can do really powerful things like very easily plot different data sets against each other and make a whole matrix of this. So here we've taken a cosine curve and a sine curve and then plotted them in all kinds of different permutations. All that kind of happens without very many lines of code. You really don't have to do that yourself anymore. Other new features really quickly. We now finally have auto wrapping of long text. If you just start writing things that don't fit on the figure anymore, it will create a new line and keep going. Contour corner masking, you can control whether you want the empty parts of your data to be kind of angled or fill the whole rectilinear box there. The color bars are finally smooth. There used to be a problem, particularly when you write them out for PDF. You'd get these sort of thin little white lines in your color bars. That's been fixed. Legend support works automatically for more different kinds of collections. And just sort of a lot of other things to mention, and I'm probably running short on time. Yeah, I have 1 more minute. So as I said, 2.0 is going to be style changes only. 2.1 is sort of going to be focused on better interoperability with other projects. That's kind of the key feature, and a bunch of other features that fit underneath that. It's going to include our traitlets work that's been done. And we also realize now that Matplotlib is a substrate for many other projects, and that's kind of happened organically. We now want to make that more distinct, more obvious, and make it easier for people to do that kind of thing. So like Seaborn and other projects that are using Matplotlib, they'll have a better time of it. So that's the future. And thank you to John Hunter, the original author of Matplotlib, and also all of our contributors, which is this huge and amazingly long list. So thanks to all of those people. And unfortunately, if your name starts with a lower letter in the alphabet, you're clipped off the bottom of the screen. But okay, thank you.
I'm Jeff Reback. I'm the one of the maintainers of Pandas, and so I'm going to show you just a quick retrospective, actually, and then sort of what's new. Okay, here we go. So we, of course, in every version have lots of enhancements, API changes, and lots of bug fixes, because we sort of want to create bugs for each, so we can have a next version, of course. So I'm just going to start briefly reviewing some of the changes in the last. This is just the last year, about a year and a half. In May 2014, we released 14. So I'm just going to go through some of these pretty quickly, just to give you a taste of what, these are mostly features. So we have multi-indexing using slicers. In other words, this is just the creation code for this. By the way, just let me go back here for 1 second. All of this is available on this website, so we'll push this up. This is just a repo that I created. Okay. So you have a standard a multi-index frame, both on the index side and the column side, and you want to know how to slice it, so this is how to do it. Basically, we allow you to relatively easily slice on both the levels, both on the index and the column side. And we say, okay, well, that's pretty interesting, but more interesting is that you can actually assign to this, and it will just work. And this was pretty hard to do prior to this. There's actually another way to do this. You can actually use a string-based query, which actually goes into the AST, and we can do some interesting things. It actually looks pretty reasonable for that. In the future, we're going to add actually something so you can do dict-like selections, so you don't have to actually specify all the levels. This is a syntax actually borrowed from X-ray. Another function we introduced in 14 was called select D-types. So you have a lot of different D-types, and you can just say, so here's a lot of different D-types, and you can say, okay, just give me a couple out of that. And these are all good when you chain things, and I'll show you that in a little bit. Okay. In version 15, released about a year ago just now, we introduced categoricals. This was a pseudo D-type, and these allow you to basically represent categorical type data or factor data, things like, say, things that fit in categories, like male or female, things like that. These can get passed to other libraries in a very easy way. And these can be ordered things or unordered things. The reason this is useful is then you can sort by them and have your own orderings. You can do min and max, things like that, that are not lexically ordered. They can be ordered arbitrarily. Further, these allow a substantial savings in the way we represent these. If you have a lot of repeated values, namely like strings, these allow substantial savings in memory. So here's a typical frame, and you can see C is the categorical column, holds a lot less, it needs a lot less memory to represent it. Okay. We also introduced time deltas in version 15, so you can represent units of time. These are basically subtractions of dates, if you think about that. So these are very similar to the date-time.time delta in the standard library, but they're friendly and they're first class in Pandas now. So you can do things like hold them as, you create them as, say, a diff or a shift, and you can hold them as first class objects in Pandas data frames or series. And there are various convenience methods that we provide to allow you to look at them in sort of an easy way and convert them to other types of frequencies. Okay, that was it. And the reason this is useful is because then you can also set them as indexes. So just like you have daytime indexes and we allow things like resampling, well, same thing here. So you can use units of time, or they don't have to be time. These are units of reference to whatever point you want to reference them to. Okay. Further, we allow a very convenient accessor. So you now you're allowed to hold these objects, could be datetimes, could be time deltas, as the actual values of, say, a series. And then we allow you to select in a very relatively convenient way to get properties on these without actually converting them to an index and back. So you can even do things like localized dates, things like that. And I'll go over this in a bit. This is actually now a first class type as well, datetimes with time zones. Okay. And the reason this is useful is because then you can actually use these in a very convenient syntax to, example, do indexing. Okay. Version 16, which came out earlier this year. So these are actually, I'll say, compatibility with the world at large. So read in a standard data set, and this becomes, I've started adopting this style where we do basically method chaining. And this assign method, it's kind of like mutate from R. And in effect, what it does is this. It basically allows you to, in a single statement, chain methods. So you can, in this case, we're adding a column, but we're not touching the original data. Okay? It's a very similar, it's exactly like this, but it allows you to do it in a convenient way here. And I'll show you why in a second. So we can then do chained things where we can conveniently, so here's an example. So we're taking the data frame, we're doing a query, then we're assigning based upon the prior statement, then we're plotting it, and it's all a nice little convenient statement. Looks SQL-like, I guess. And the reason this is useful is because then we're going to have, oops, let me go, sorry. So here, this is exactly the same statement, except here, I'm actually, what I'm doing is I'm piping this to Seaborn, actually. And this is a, you can also do this with Matplotlib and Bokeh soon. This basically allows you to do things like substitute it right directly in. And you can say, and it just allows you to put that everything in the chain. Even things that don't directly support it, we just pipe it right to it. Okay. In 16, we also introduced sample. This allows you to conveniently just select out sample by how many numbers I want, a fraction of the whole frame. This is a row selector, or by percentage sampling here. And so creating, say, like test and train data becomes very straightforward to do. I won't go into this. We also added a categorical index, just like we have categories. So representing repeated data becomes very efficient. And I'm going to go to the next thing here. Okay. In 17, we just released this about a month ago. So one of the big things we did, we released the GIL on a lot of operations. I have a little blog post here. The idea is, of course, that you can use threading to gain performance. And one of the reasons we did this was another project called Dask. Allows you to very conveniently, so here's an example. This is doing a group by in pandas. Just by doing this, you get performance for free because we released the GIL, and this is using multiple cores on your machine for free. Okay. We introduced the .plot accessor. So this, we used to have you used to be able to do .plot and put a kind in there. So we basically allowed introspection, so you can just do this as an accessor. Just becomes more convenient from a syntactical point of view. Okay. We made date times with time zones a first-class data type. And this is another, so you can now manipulate these just as efficiently as regular datetime, naive datetime 64s. Okay. One big API change I'm going to mention is that for a long time, series, you had this weird thing. You had .sort, which was in place, and then you had .order, which was not in place. And then for frames, you had .sort, which was not in place. So it was really confusing. So we introduced a .sort values, basically a new keyword to do sorting on the values. And then, so now it becomes every object has sort index or sort values. Should hopefully have less confusion. Okay, now I want to show, now, what's in the future? So I'm just going to, okay, so we have a bunch of things on the plate for the future. Potential, some more D types, namely like a period or an interval D type we're going to add as a first class D type. We're going to add some support for integer NA, and we're going to allow you to, in a very easy way, dispatch to Numba and to Dask. So here's my picture of the future right here. So this is I did a graph of this last time, about a year ago. And in this picture, it's the same as the other picture, except I have these shaded boxes. And these are potential things that we could actually dispatch to, which would be a nice thing to be able to do. And in fact, we give these almost for free. Pandas will just automatically use them when they're available. The last thing I want to show is this is going to be actually in 17.1, I think. This was just a long time request by some people, or by a lot of people. So up till now, we have a rather boring HTML representation of a data frame. So, okay, still boring, except now we have this new keyword, or this new property called style. And then you can do things like this. This is using templating. And then we can do things like this. And this is all chainable. That's why I'm showing this. It gets more exciting. You can multiply chain. Ooh. And you can do subsets here as well. Then it becomes even more interesting. So we have some built-in methods that work in the style object. This is completely overridable, actually. And then you could do things like mix and match them. This is an interesting one. And then, of course, you can do this. Ooh. Hover templating. Like that. This was another, I don't know where you would use this, but you have this. And last but not least, of course, you can hook this up just like any other thing to an interact widget. Okay? That's it. Thanks, guys. All right.
Hey, everybody. Can you hear me? Yes. So I'm Andreas Mueller. I'm one of the core developers of scikit-learn and one of the 2 release managers together with Olivier Grisel. I'm going to talk about what's new in scikit-learn 0.17 that was released last Thursday. So the slides are a bit rough because I had to do the actual release. So there's one thing that is important, a deprecation, so something that will change in the future that I didn't put on the slides. So as you might know, if you work with scikit-learn, you have your NumPy array of data where each column is a feature and each sample is each row is a sample. And now make sure that you always use a 2D x. It should not have any other endim than 2, your data. A lot of people started passing 1D data, and it's slightly confusing because in some methods it was using that as features, and in some methods it was using that as samples. And it led to a lot of subtle bugs. So always pass 2D x. Anyhow, so it's still everything works as before, but we're not going to support this anymore in the future. So now to do actual cool new stuff that released last Thursday. One is LDA, which now stands for latent directly allocation, which is a topic model using online variational inference. If you're not familiar with topic models, this is like, on the left you can see this is like a fancy graphical model where you assume you have a corpus of text data usually, and you assume there are some different topics. You have a fixed number of topics usually, and you say each document is a combination of different topics, and each word is drawn from the distribution for each of these topics. And then you can do some visualizations. I'm not sure if you can read it on the right here. We choose 10 topics, and then there's sort of the most common words for each of these topics. This is the 20 news group data set, I think. And you hope that these topics sort of correspond to what is being talked about in your text. So this is a very popular model, and we now finally also have an implementation of that in scikit-learn. Actually, this is the fastest implementation that I'm aware of now. We're slightly faster than Jensen because we did some more Python stuff. So this is based on the code by Matt Hoffman and was implemented by Qihua Yao. Another cool thing that we have now is a new solver for logistic regression and retrogression called SAG. So this just makes logistic regression and retrogression faster if you choose the solver. It's particularly well suited for large and very high dimensional data. So if you used the SGD classifier before, you might want to use logistic regression or retrogression with SAG solver now. It needs to fit the data into RAM twice. So if your data is not gigantic and you have enough RAM, you should use the SAG solver. Another thing that we changed is actually now a new default solver for non-additive matrix factorization. I'm not going to explain that, but so we had a projected gradient solver before. Now we have a coordinate descent solver, and it's like a factor maybe 1.5, 2, or up to 5 times faster than the old solver. So non-additive matrix factorization in the new version just got much faster in all cases. Another thing that gets much faster is the t-SNE manifold learning method. So that's something method to visualize high-dimensional data. I plotted here my favorite examples of using the digits data set. So this is a completely unsupervised method that always makes a lot of very, very pretty pictures. So here, this model didn't know anything about the data. You just gave it some raw pixels, and you see that it perfectly grouped different kind of, these are different digits, and grouped them together in a 2D space. So So it's a very nice method to visualize high-dimensional data, and it got faster in this new implementation by a factor of 10 to 100 sometimes. So a new model that's in there is kind of a quick helper model. If you're familiar with scikit-learn, then you probably know about pipelines. So pipelines are a way to chain multiple transformations of your data with some classifier. And that's very useful to do cross-validation grid searches over a more complex pipeline. It means that you need to write these transformer objects, which is sometimes like a bit annoying. But now there's this function transformer, which basically creates a transformer object for you from a callable. So if you want to do something very simple, like just do a logarithm and plus of your data plus 1, you can say function transformer np log 1p, and it just applies this function. So this is an easy way to go from a function to a scikit-learn transformer, if you just want to have a static function applied. So that's very convenient. Another kind of convenience method that we added is the voting classifier. This is basically done to build arbitrary ensembles. So you just pass it a list of multiple classification models, and it supports to do either hard voting, which means it predicts the class that was most frequently predicted, or soft voting, which means it averages the probability estimates, and then predicts the most likely class. So this thing is very, very popular in Kaggle competitions, for example. A lot of people use these voting classifiers. Another new classes that got added were two scaling models. So these are for pre-processing. One is a robust scaler that kind of subtracts the median and then scales by the quartiles. So that is more robust than using the mean and the standard deviation. And a max app scaler, which is sort of, it scales down the data by the per feature by the maximum absolute value. And that sounds kind of odd, but the important thing is that we wanted to have some scaling for sparse data. And it's very weird to scale sparse data because you want the 0 to be at the same spot, but you want to limit the range of the data. So this max app scaler is actually what you want to use if you want to scale sparse data and you want to keep the 0 in the same place. Oh, something I added that is not that grand, but it was asked for really a lot, and I hope it's useful, is, so this is like the API documentation you might know from the reference guide. I added this line, which gives you a link to the user guide, so you actually can go back from the API documentation to the user guide, which before you could not do. So very briefly, I want to talk about what we will have in the future in 0.18. So these are things that are actually in the development branch. So if you check out the development branch, you can have them already. One is a complete rewrite of the Gaussian processes. That adds two things. One is you can do now basically kernel engineering. So people that do Gaussian processes usually want to create some crazy kernels. Here's a classical data set from the Gaussian process literature. You want to model this time series, and you can see sort of the fed points on the left are the training points, and then you want to like see how this time series develops in the future, and you have this blue line, which is the prediction, and the gray, which is the uncertainty. And so if you're a Gaussian process expert, you might want to write down a kernel, and the kernel that's actually used here is written down below. So it's a combination of a lot of RBF kernels and sinus kernels and rational quadratic kernels and I don't know what. So we can now do in scikit-learn arbitrary combinations on kernels, and we can also learn all of the parameters of these kernels efficiently. So all the like floating point numbers you see there, they're all learned from the data using using maximum likelihood on the data, which we can now do much more efficiently. In the old version of, or in the current version of scikit-learn, we use a gradient, a non-gradient-based method, and then the new version we use a gradient-based method. We also have in the development version neural networks. It's just very simple multi-layer perceptrons, so there's no convolutional nets, and we don't have GPU support. But if you just want to like compare your random forest to your neural network, you can do this easily, and then you get some like nice filters on MNIST, which is what you always use with neural networks, obviously. In the new version, there will also be improved cross-validation. Not sure if this is visible. And I messed up current and future, which is also good. So on the right-hand side, where it says future, this is what it currently looks like, where you have this k-fold object, and after you instantiate it, you can just iterate over it. And you get training and test set parts for each split. And you have to give say how many folds. In other iterators, you often need to say how many data points are there. And if you need to say how many data points are there, you need to know what the data is in advance. On the left-hand side, where it says current, this is a new version, where you have the split method. And the split method actually gets the data and also the labels. And so you can more dynamically generate the indices based on what your data actually is. This allows you to do nested cross-validation, as shown here below, where you have grid search, and then some inner cross-validation, and some cross-val score that cross-validates the grid search. So there's nested cross-validation. And so this probably crashed before, because the number of samples in the inner loop might change. But you need to know the number of samples in advance to create a cross-validation object. But now this is possible. So this is also in the new development version. And in the new development version, we'll also have faster PCA. So there's sort of a plot of running time on the x-axis, so you want to be to the left, and explain variance, which is a measure of error. So you want to be down and to the left. And there's a comparison. Blue points are master, and red points are, blue points are what is now in the release version. Red points is which will be in the development version. And basically everything went a lot to the left without getting much worse. And so now, yeah, PCA will be much, much faster in the future. And that's it.
So I'm Brian Granger, and I'm one of the lead developers of Project Jupyter and IPython. And I want to talk to you about some things we've been up to for the last 6 months to a year, and then also talk about some of the things that are coming up in a new release. There's a lot more than I can talk about in 10 minutes, and I have a longer talk tomorrow that'll go into more detail about the technical aspects. The first thing that we have is a, you can't see what I see, which is difficult. There we go. Nope, you can't. That's really quite odd. So the first thing we have is a new, well, you still can't see what I see. There we go. A new website. We've been working this last summer with a designer, and this is what the new website looks like, although the aspect ratio that you're seeing, well, that looks okay. That does not look, looks a little odd. And compared to the previous website that we had, this is a substantial improvement. We have a button here. You can click this, and I guess I don't have internet. I did a second ago. But you can try out the notebook on try.jupyter.org. We're hosting notebooks and Docker containers there, mostly for exploratory purposes. That's being hosted by Rackspace, and there's quite a few kernels that are running there. Python, R, Julia, and Scala with Spark as well. The next thing that we've been up to is this last summer, we released the first version, or version 4.0 of IPython and Jupyter. And this was really, I won't try to actually show you anything. This was the first release of the project under the Jupyter package name. And so a lot of you have probably noticed this if you tried to update IPython or Jupyter in the last few months, that you will now get Jupyter packages. The notebook is now under the Jupyter GitHub organization and package. So for example, the command line command to run to start the notebook is now Jupyter space notebook rather than IPython space notebook. IPython continues to exist as a project. It is now basically the Python specific parts of the project, namely the Python kernel, IPyWidgets, and then also IPyParallel and some other infrastructure. Earlier in the spring, we had been working with GitHub for quite a while, and they released, built into GitHub itself, rendering of notebooks on GitHub. And this is just an example. Yes, please tell GitHub how much you like that. They did a lot of work on that. And this is a great example. This is one of the notebooks in Cam Davidson-Pilon's excellent book on Bayesian methods that you've probably seen. Or actually not Bayesian methods, but probabilistic PyMC stuff. Governance. We have actually been thinking a lot about governance aspects of open source. And from a technical perspective, this is not particularly interesting. What we're finding, though, is that as this community engages in collaborations with companies, governance becomes very, very important. What we have found is that the main barrier to adoption and contributions from corporations is not technical details. It's things like governance. It's things that managers and lawyers at large companies worry about. From their perspective, honestly, they view developing new features as fairly cheap. What's expensive is lawsuits. And so governance is the type of thing that makes their executives and lawyers sleep well at night and feel good about contributing to the project. We have a new Jupyter governance repository that has all the details about how we run the project and make decisions. And I encourage you to check this out. And also I encourage other projects, open source projects in this space, to think about your own governance. It doesn't have to look like ours. But it can be very useful to have some of this stuff written down. For us, this really started just by us writing down what we were already doing. Over time, it's allowed us to evolve what we're doing. We've also created a new GitHub organization called Jupyter Incubator. We were finding that there was a lot of interest from the community to start new sub-projects that were a part of Jupyter, but there was still a lot of uncertainty and questions around those projects. And so we have created a Jupyter Incubator and a very lightweight process for the community, including you, as well as corporations, to start new sub-projects that you would eventually like to become part of the Jupyter project itself. The response has been fantastic. Here are the existing incubation projects. A number of these have been done by IBM, another one by Bloomberg, and another one by Microsoft. And then also Kyle Kelly, who's one of our core devs from Rackspace, is involved in a couple of these as well. So where are we headed next? Here is a little bit about our roadmap. I should mention the last release that we did, 4.0, really didn't have many new features. It was really focused on us refactoring the code base and splitting it into separate GitHub repos and packages. In practice, what that meant was that 4.0 was mostly a bug release, not a bug fix release, but a release where we got to introduce a lot of new bugs and make your life a little bit miserable. We apologize for that and just thank you for your patience. 4.1 of the notebook should be coming out in the next month, and hopefully we have fixed all of those new bugs and existing bugs, and we have a few new features that I want to show you quickly here. The first is multi-cell selection and actions based on that. So here, you can't see what keys I'm pressing. This is J and K, or up and down. And then if I hold down Shift, I can select multiple cells. C will copy those. V will paste those. And so you can do both contiguous selections, so escape clears the selections, or you can go and do discontiguous selections, so I can delete those cells. There's a number of different actions. A lot of the common actions are wired into this. Probably not all of the actions that you want to use with this are working yet. We're trying to be a little bit conservative because the semantics around some actions on multiple cells, especially when there's a discontiguous selection, are not completely obvious. But that's one thing we're very, very happy about. Next is, let's just create a bunch of new cells, copy, paste, paste. So let's say I have a large notebook and I have a variable, maybe C, that's in multiple places in the notebook, and I want to rename that. Currently, it's really painful to do that. You can press F. I want to search for C, replace by D, and I'm done. All right, so you've got multi-cell find and replace. You can do the replacement only on the selected cells, and you can also do regular expression-based searching as well. Also, the new release will have a command palette. So this is similar to the command palette in some other text editors and development environments. So if you do Command-Shift-P, you get the following, and then I can say unmark all cells. And this is really useful because the notebook has a lot more actions that are possible than keys on your keyboard. And so we're not able to bind a keyboard shortcut for everything that you'd want to do. And this command palette gives you access to the full set of commands that are possible on the notebook. One last minor thing, it's silly, but I think it's really important, and that is under kernel, there's now a restart and run all option. And in our minds, this is really to address, I think, one of the problems we've seen in usability of the notebook, where you write a notebook and you have some order of cells and some order that you've run those cells in the kernel, and you save it and you send it to someone, they open it up, run all the cells, and it doesn't work. And the reason for that is that the state of the notebook document is completely separate from the state of the kernel. And you may have, when authoring the notebook, run cells out of order. And so restart kernel and run all is a fantastic way for you to make sure that that notebook in its current state does what you think it does. Other thing, how am I doing on time? 1 minute left. Fantastic. We have a lot of new stuff, of new things coming up. So the first thing, so 4.1 that I just talked about should be out in the next month. 5.0 will be the first of a series of releases focused on a lot of new front-end work in the notebook. In particular, 5.0 is going to have a prototype of something we're calling the Jupyter Workbench. Initially, this will be a new page in the existing notebook web application. And the idea is that it will, on a single page, allow you to combine multiple different components. So you could have, for example, two text editors tabbed on top of each other next to a notebook above a terminal. So things like that. The first release, we're targeting to have a file browser, a text editor, and a terminal. It will not have the notebook initially. Getting the notebook into this single page layout is a lot more work. Also related to this is that we are changing how we write and package our JavaScript code. There's a lot of people who want to take the different building blocks of the notebook and reuse them on different web pages. Today, that is really, really painful. And in the future, or the very near future, we will have a lot of independent, loosely coupled NPM packages. So here are some of the new repos that we're doing this work in. So for example, if you want to have a code cell on your web page that can talk to a kernel, you can npm install Jupyter.js services, and then probably Jupyter.js input area, output area, and cells, and just use that to throw a kernel and cells on your page. Or you might also want a full notebook on your web page. And so this is sort of the plumbing that we're doing underneath the new user interface that we're building. In the long run, so this is the next +2 release, we will have standalone output areas in this paneled layout system, and also the ability to hook up text editors to these output areas as well. Obviously, eventually the notebook will show up in this environment as well. And I encourage you to check out this roadmap. It's under the Jupyter roadmap, or I should say, there's a pull request with this content against the Jupyter roadmap repo. We have a lot of other exciting things going on in IPyWidgets and Traitlets, and all the other projects as well. So please watch this space for details on that, and I think I'll stop there. Thanks.